Well, here we are. It's cold. And yeah. Anyways, we'll just move right into number 1, talking about the inversion problem. I'm not entirely sure the best way to explain this without doing a novel, so I'll just show you the work that we did. You just do the reciprocal, the cross, because I can't talk right now, and you come up with 4 different products, and the products that you come up with, I'll also spare you from having to listen to it, but basically products 1 and 4 will have single centromeres and normal allele arrangements, no deletions or duplications. And then for product 2, you'll come up with some deletions of some of the alleles, and it's acentric, so it doesn't have a centromere. And product 3 contains duplications, but it is dicentric, so it has 2 centromeres. And so basically 1 and 4 are considered the normal ones, and then 3 and 4 just kind of get lost in meiosis.
Yeah. 2 will go. A is meiosis 2 and mitosis. B is paracentric inversion. C is Turner syndrome and familial Down syndrome. D is liver cells. E is Cri-du-Chat or chat, and type A hemophilia. G or F is duplication, and G is alternate.
Nice.
We looked those up in the reading. That's how we found them.
So for 3A, we base this off of the fact that humans have 23 pairs of chromosomes, so 46 total. And so for Turner syndrome, you come up with 45 chromosomes. For Jacob syndrome, you come up with 47. For Cri-du-Chat, you come up with 46. Familial Down syndrome, 46. And type A hemophilia, 46. For B, which are not associated with Charcot-Marie-Tooth, triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction. For C, which ones are associated with Klinefelter syndrome, aneuploid, trisomy, and non-disjunction. For D, which ones are associated with type A hemophilia, and we both came to the agreement that none of them applied to it.
Only inversion, but it was on the list.
Yeah.
Okay, so for 4, I didn't really do the exactly how it was in the PowerPoint, where there was like them coming together like that, and changing against each other. But I showed where they crossed over, and I just imagined there was double of each one of these. And so for alternate segregation, you're going to have 4 cells. I just did 2 of them because 2 are the same. I just did one type of cell with the other type of cell times 2 on each. The alternate, you're going to get your original non-translocated or non-translocated chromosomes in one gamete, and then for the other 2, you're going to get the rearranged or the translocated ones together. And they're going to be non-viable, so only half of them are viable in the alternate segregation, and it's more common. In the adjacent 1 segregation, the original the original of the first chromosome will be with the translocated of the second chromosome, and the other 2 gametes, the original second chromosome will be with the translocated first chromosome. And you can say I drew chromosomes, but they're all times 2, so there should be 4 here. And these are the chromosomes orders. And then for D, for the adjacent 2 segregation, actually the they don't separate. So chromosome 1 and the translocated chromosome 1 are going to be in the same gamete. There'll be 2 of them, and then the original second chromosome will be with the translocated second chromosome. There's 2 of those, and all of those that I just mentioned are non-viable. That was probably the question. There we go.
So for 5, talking about cats, and they have 38 total chromosomes. So for a triplet cat, you'd have 19 times 3, and you'd come out with 57 total chromosomes because there's 3 sets. For B, a monosomic cat for chromosome 12 would be 37 because you're taking away a chromosome because it's monosomic. C, a cat that has suffered a terminal deletion on chromosome 7 will have 38 because deletions don't affect the number of chromosomes. For D, a cat that suffered a Robertsonian translocation would have, we decided on 37 chromosomes.
We talked to David a lot, tried to help us, but so because what we understood was that there's 2 of one kind and 1 of the other kind. Let's say the chromosome 2 of 17 and 1 of 18, and then there's a Robertsonian chromosome that takes from both of them. So that would be 4 total, but I guess we're not counting the Robertsonian chromosome, so we say that it's -1 instead of similar, or than the normal amount. So yeah, we'll find out. I think David texted you about it.
For E, a cat that has suffered a reciprocal translocation between chromosomes 6 and 9 would be 38 because translocations don't affect chromosomes.
Very good.